Hello, everyone. Thank you for joining us for today's webinar, Artificial Intelligence and Machine Learning, Unlocking the Benefits of Automation. My name is Adriana Grotto, and I am a Senior Business Development Representative here at SDC, and it is my pleasure to be moderating today's webinar. Before we begin the presentation, I will first cover a few webinar housekeeping tips. First, everyone has two audio options for listening in on today's webinar, computer audio or phone. If you hear any interference either on the phone or through your computer, the best way to troubleshoot is simply to switch to the other audio option. Please know that we are recording today's webinar and will be sharing the recording with all registrants via email next week. We encourage you to share the recording with friends, colleagues, and anyone you feel would benefit from this webinar. Finally, if you have any questions or comments throughout the presentation, we do encourage you to communicate with us using the questions section of the webinar portal. If your question references a specific slide, please include that in your message. We should have about 10 minutes available at the end of the presentation for Q&A, and we will do our best to address any of the questions that you submit within that time frame. It is now my pleasure to introduce Dr. Dale W. Usner. Dr. Usner is Chief Scientific Officer and Senior Vice President of Strategic Scientific Consulting at SDC. He has over 25 years of experience in the clinical trial industry. Most notably, he has significant experience supporting over 100 regulatory body interactions, including with the FDA, PMDA, EMA, and advisory committee meetings. He specializes in study design and clinical program development support. Thank you again for tuning in for today's webinar. At this time, I will hand it over to Dr. Usner.
Thank you, Adriana. Welcome, everyone, and thank you for joining us today. Applications of artificial intelligence and machine learning span many aspects of clinical trials, from drug discovery, identifying therapies targeted to the specific biologics of disease, to patient recruitment, compliance, and retention, where one can parse the clinical trial protocol for enrollment criteria and search electronic medical records to identify subjects who may be eligible, as well as those who would have improved compliance and retention. An additional concentration is in the creation of synthetic patients in order to reduce the number of subjects required to be randomized to placebo or an inferior control treatment. And finally, software as a medical device, where the application is used to either diagnose a disease or to guide clinical strategy. As a data service provider, we are focused on applications that standardize and automate processes with a concentration to lower costs and maintain high quality in less time. Our current applications include CDISC standard data tabulation module, database design specifications, user acceptance testing, role and training-based study access, and smart listings for data review. Another aim is driving data insights for robust decisions through comprehensive reporting and algorithms using both structured and unstructured data. Here, our current applications include reporting on key performance, quality, and risk indicators to inform quality-based monitoring, identifying subject characteristics that would be correlated with safety or efficacy events, as well as in the creation of synthetic patients and analysis strategies therearound. With this in mind, it is my pleasure to introduce the speakers for today's webinar, Unlocking the Benefits of Automation, who will walk you through the current state of our development lifecycle of ongoing applications and learnings therefrom. Julian Phillips, Senior Manager, Data Insights and Automation, has 15+ years experience applying data science and software development, including learning algorithms and automation towards improving efficiencies of processes and gaining insights into data. Bharti Gogula, Manager of Statistical Programming, has 12+ years experience in statistical programming for clinical trials, including overseeing implementation of the SDTM. Julian.
Thank you, Dale. I'm really excited to share the progress that SDC has made in automation and machine learning in the past year or so with you guys. So today, here's the agenda. We'll talk about the overall vision, data standardization, the benefits of data standardization. And then I would like to talk about a couple of the automation projects that we have undertaken that leverage some of the standardization we've undertaken. The first is study access security, and the second is business development protocol bid automation. Finally, as Adriana mentioned, we will have about 10 minutes at the end for all questions that you may have. Our vision. The SDC mission for data is as follows: to drive insights into clinical trial and operational data through standardization, automation, and machine learning while ensuring efficient and replicable outcomes. You will notice that standardization is listed before automation and machine learning. That is because without wholesale buy-in of standardization throughout an organization, the time to complete automation projects and machine learning models is much longer at a minimum. Oftentimes, both are very difficult to do and much more error prone. Also notice that it does not say data standardization, but standardization. This is because there are other items that can be standardized, such as business processes, templates, and folder structures that also improve the ability for automation and machine learning. Do not only think about naming conventions. So why does the lack of standardization lead to slower turnaround and performance in automation and machine learning? This is because without it, exceptions will need to be made. Values will need to be transformed. Maps will need to be created. This can take a lot of time and introduce new sources of error. Additionally, oftentimes you will find yourself duplicating efforts. One project may need a map that is slightly different than a different map. When things are standardized ahead of time, these duplicated efforts will not take place. I would like to define the terms that we will be using later on in this presentation, specifically artificial intelligence. This is a term that can have many different meanings depending on the context, the industry, and even the era that it was spoken in. We use it as a general term for any computer system that simulates intelligent behavior. Machine learning is a subset of AI. This is an application where the system learns and improves over time based on observed data. One important component of machine learning is the virtuous cycle. Simplified, here is the virtuous cycle. You start by using data that is already labeled, so therefore you know the result of that data, to create a machine learning model. It can be a model of any type. It could be a logistic regression model, it could be a decision tree, or it can even be a neural net. The virtuous cycle works on all of them. Once that model is deployed, we would apply predictions on a new record. This is an unknown record. We don't know what the status is, but we are looking to predict some attribute of it. That prediction is then output, and then a subject matter expert will determine if the predictions are correct. Then that newly labeled data is added to the model, and the model can be retrained and redeployed if needed. I would like to walk you through an example of a machine learning model and how the virtuous cycle takes place using something that most people are familiar with, and that is email spam detection. I want to emphasize upfront, this is a greatly simplified example. Most email providers would take into account the conversation history with the email address in the past, the reputation of the domain sending the email, and even the age of the email address when classifying emails. In this example, we're going to imagine we only have the text of the email and nothing more. So first step in the Virtuous cycle is to use the data to create a machine learning model. Let's pretend we have 10,000 emails along with whether or not they were spam. We've collected those emails, and next we need to process the text of the emails. Now, this can involve natural language processing and using things such as stemming, which is the removing of words, the removing of the ends of words so that they become common. This would mean runs and running both became run, which is the root word. You can also use a lemmatization, and that is changing the word to its most basic format. This helps correct for tense changes as well as plural subjects. For instance, was, is, and are all forms of the verb to be. So the lemmatization form would be. Finally, we create and deploy the model after training it. The second step in the Virtuous cycle is to apply predictions on a new record. In this example, a new email has arrived in the inbox. We process the text of the email. It is vital that the processing that you do here is identical to the processing that was done in the initial model. This means all stemming actions, all lemmatization actions, any word removal, or any other action is taking place identically. Otherwise, the output prediction of the model is not valid. Finally, the email is categorized and moved either to the spam folder or the inbox folder based upon its classification. Historically, the first models for spam detection used a naive Bayes algorithm. This determined the likelihood that an email was spam or not based off of the combination of words in it. For instance, an email that has the word prince, wire, and money is very likely to be spam. These words, especially when placed close together, indicate a high likelihood of spam. The naive Bayes algorithm is capable of using word proximity as a feature when classifying. In the final step of the Virtuous cycle, the SME determines if the predictions are correct. In this scenario, you are the subject matter expert. You are the person who will determine whether or not that email was truly spam. So you open the email and you read it, and you either click on the top that it's spam or it's not spam, depending on your email provider. That label is updated, indicating the true classification of the email. And then you iterate and you can create a new model. We started with 10,000 emails. Now we can deploy a model with 10,001 emails, slightly improved. This example shows how leveraging the Virtuous cycle allows a model to improve itself over time. Data standardization. Data standardization provides the solid foundation that is needed for other applications, including automation and machine learning. We will first talk about EDC, electronic data capture data, as that is the first place we are looking to standardize data and to use it within other applications. So the reason that the data is not standard to begin with can be varied, but some instances include different clients have different preferred standards. So the same form and the same question capturing the same data may have different naming conventions due to client preference. Similarly, forms can contain multiple tests or could be separated one form per test depending on the preference of the client. The data types themselves may come back differently than you expect. A numeric data type may come back as a string, and a date may come back as a string. These need to be transformed. Finally, different EDCs can have different data models underneath, and accounting for the differences in the way they store data that the front-end user may not see is important for standardization. The virtuous cycle is also used in our data standardization process. We aim to map all forms and questions into tables and variables according to CDISC standards. I want to have a note on terminology here. When I say form and question, I mean the raw EDC data, while tables and variables are the associated standardized names for the forms and the questions. The first step in this process is to use regular expressions, which is a form of pattern matching, to extract various parts of the question name. Those are then matched to known CDISC standards. Specifically, we're using the SDTM Implementation Guide 3.2, as well as C- and SDTM control terminology to match. Any parts that are unmatched, therefore they are not a part of those three controlled terminologies I just mentioned, are put through a machine learning model to best guess their actual part name. Features in this model include the form name, other parts of the variables that have been identified, and metadata about the variable itself. Numeric data types may have the mode, the median, the standard deviation, or the range, all included as a feature within that model. Finally, all the parts that have been matched are put back together and verified by subject matter experts. Their response is used to update whether or not the machine learning model was correct, which will of course lead to more accurate predictions in the future. The end result is a standardized variable name. Across 5,000 plus variables in 17 studies, 65% are entirely composed of valid naming standards. This means the entire variable is used with controlled terminology. 90% are at least partially comprised of valid naming conventions. This means that 35% that are not entirely comprised will have to be sent through the machine learning model at some point. I would like to give a standardization example now using these three variables. Given the variable name, the first step is to determine the data type. By examining the data for each variable, we can determine one of four types: numeric, string, datetime, and flag. Flag is also known as Boolean and contains one of two values, such as true, false, or yes, no. Next, it is parsed into separate components. In this example, the underscore is the separator, which leaves each variable with two components and leaves us with 6 total components. Each of these 6 components is compared against the control terminology lists being used. First, the wildcard ORRES and wildcard stat are able to be matched. These values come directly from the SDTM terminology guide, where the wildcard indicates the domain in which this variable belongs. We have matched 3 of the 6 as prefix types from the SDTM implementation guide. We also know from that guide some additional information. ORRES is a result or finding in original units, while stat indicates the completion status. We now need to put our roots, which are the 3 remaining components, through the algorithm. IOP and SysBP are standard test codes. Reading is not. This means that reading will have to be put into the machine learning model to determine how it should be standardized. In this case, it becomes standardized by using the term tbut. And that's because in this example, this variable came from the tear breakup time form. Therefore, that is why that is a standardized variable. 2 of the 3 variables form variable names are identical to their standardized names, while 1 did need to be transformed. The benefits of standardization include the ability to quickly iterate over models and to release new automation software. But next, I want to talk about our first use case for standardizing variable names, and that is its usage within SDTM. We chose to use the process of creating an SDTM dataset as our first use case because it is a process that is seen in every study and it can take quite a bit of time to complete. By implementing our process, we can reduce the amount of hours needed by over half. By using the naming standardization up front, this process becomes much more consistent across all studies. Our process consists currently of 2 steps. The first is a program that groups variables of the same category together into a specification sheet. Second, that output is used by a SAS macro that eventually outputs the SDTM dataset. By having predictable input, the SAS macro can be used across all studies with minimal modification, rather than needing to write individual SAS code for every single study. You can see the time savings that this would generate. Let's talk about the variable grouping program, which is the first step in our process. This program works slightly different based on the domain type, and we currently support 2 domain types. However, we will eventually support all of them. The first is the finding domains. This groups variables together that contain information about the same test. It then classifies them as either a value, a completion status, or a visit date time. We also have other classifications. The other type of domain it currently works on are event domains. Here, it looks to match the variable name to a group of standardized variable names that should exist within that event. All outputs will have a % probability calculated by the model. As SAS programmers use the output, they will flag incorrect matches. This allows for the model to improve for future use, another example of the virtuous data cycle. Here's an example of a findings domain. Giving the following 6 variables, how do they get grouped? Well, right off the bat, we can identify that we have 3 test codes here: systolic blood pressure, diastolic blood pressure, and heart rate. And each of those variable names is easy to identify because we can see we have the ORRES prefix indicating the original reading as a value. Similarly, the completion variable is easy to pick out for HR because it has the stat_HR. However, you will note that both systolic blood pressure and diastolic blood pressure share the same completion variable. Intuitively, this makes sense, as you actually only need 1 test for blood pressure, but it returns 2 values. Therefore, we have the same completion variable used for both blood pressure tests. Finally, they all have the same date, which is the visit date that these tests were all conducted on. There are additional components that we can use to assist the matching, such as the position, which would be standing, sitting, or supine. Currently, we have run this on 17 studies using both findings and event domains and the grouping algorithm. For findings domains, 50% of the matches are returned with over 80% confidence that they are correct. And for event domains, 70% of matches are returned with over 80% confidence that they are correct. However, both models are not very mature yet, and we expect those values to increase as we leverage the virtuous cycle. Now that I have explained how the specification sheet is generated by grouping together a set of variables with information about the same test, I want to pass it on to Barty, who will explain how the SAS macro uses that spec sheet to generate the final SDTM dataset. Barty?
Thank you, Julian. So SDTM development generally starts with a set of specifications. Once the grouping program discussed earlier runs through the data, it produces an Excel specification sheet, which the study project lead will review and make updates or corrections, then pass it on to the SDTM programmers. We'll talk more about what the leads would review in the next slide. Once the programmers have the specification, a SAS macro that we developed in-house is used, which produces an executable SAS script. The reason for developing a SAS script versus developing a macro that produces an SDTM dataset directly is because, number one, we have external data in addition to regular data that is captured in the database. Having a script would then provide flexibility of adding or modifying this code to account for these external variables that are mostly non-standard. The second reason is producing the script is important to have and maintain an audit history for each of the SDTM codes. The macro produces an executable SAS script, which will have a log when it's executed and can be shared if required to show the audit history. This also provides traceability in how the data got transformed from the raw data into a more standardized SDTM format. This script now can be modified or adjusted based on study-specific requirements, which would eventually produce the SDTM-ready dataset. Next slide, please. The first snippet we see here is an example of the specs generated from the grouping algorithm. This is basically an Excel file with a lot of columns. The AI team gets input from stats on what to look for in terms of standard terminology. For example, we'd give them a domain name, a category name, a test code, or a test name, like you see in columns A, C, and D in this example. The algorithm will then parse through the raw data sets, and it tries to match the right raw data variable with the right test and category in a specific SDTM domain. We're looking at an example for vital signs domain here, and this is how the spec looks once the grouping algorithm has ran through the data. As you can see, the columns E, G, and H, which are variable name, date, and not done variable columns, all of these contain raw data variable names, which are coming from the raw data set named vital signs, which is showed in column B. A couple things I'd like to point out in terms of reviewing this spec. Number one, we see column I for supplemental variable, where one raw data variable got mapped to systolic blood pressure. The algorithm will look for variables excluding common database-related variables. It also excludes standard variables that would belong in the primary SDTM domains and flag the rest as non-standard. And these non-standard variables are the ones that get mapped to supplemental domains. In this example, we have this variable collected to check if systolic blood pressure is greater than 10 mmHg from baseline visit. The question is collected as a yes/no response on the CRF, and the model was able to predict that this is a non-standard variable and is able to map to the right test code. And you'll see that it's only populating on the systolic blood pressure row. Secondly, I'd like to talk about the column F for units. You'll notice that this has a text value instead of a raw data variable name. For this example, the study protocol didn't collect units for vital signs tests on the CRF. Instead, the units are predefined in the study protocol. So this column would be empty when it comes out of the grouping program. During the spec review by the study lead, they can easily populate the pre-specified units for each of these tests as per the study protocol, and that's what we see here. Our SAS macro has the functionality to read this as a text value or a variable name, depending on what kind of information is populated. Just by looking at the spec as a whole, we can confidently say that the algorithm mapped the right variables from the right data set to the right test, and we can say that the percent predictability for these is 100%, which is what we see in the last two columns, J and K. The percent in column J is telling us how well the category matches the form name, which is vital signs here. The percent in column K is telling us what is the percentage that the variable matches the right test. Anything that is not 100% will obviously be reviewed more carefully, and since the algorithm applies machine learning methods, as and when it parses through more and more data, it learns more patterns and will eventually return higher accuracy. The second snippet we see here is showing how the macro is called. The macro uses the spec file that we discussed about as input and produces a .sass file, which will hold a script like what's shown below. This script can be modified to adjust for study-specific needs and can be pre-processed or post-processed. Next slide, please. Okay, so this slide shows the final transformation. The first snippet is how a dataset looks like in the raw format. The second snippet is after it is transformed using the specs generated from the AI tool and combining it with the SAS macro. As you can see, it is pretty close to a standard SDTM domain for vital signs, with standard variables like test code, test name, vital signs category, vital signs original result, and original units, etc. This entire process is very efficient because, number one, the spec is automated now, meaning it reduces the manual work that's put into generating a regular SDTM spec, especially for standard CRFs. And number two, the script that the SAS macro generated already writes a lot of code that will consistently follow a standard domain structure. This again, without the macro, would have been a manual process when going from study to study. And so with the macro, we can automate this and can eventually produce a submission-ready dataset with little or no modifications to the script. In conclusion, the key takeaway here is that this whole process, which is using the spec generated from the grouping algorithm combined with our SAS macro, can reduce about 60% of our manual processing time for tasks that are repetitive in nature. This could potentially mean quick turnaround times for study SDTMs that follow a standard CRF, while consistently maintaining industry standards and ensuring that we're always producing submission-ready datasets with high quality. With this, I'd like to hand it over back to Julian for the next set of slides. Thank you.
Thank you, Barty. While SDTM is the first use case, there are other benefits to data standardization that we'll be leveraging over the next couple quarters. First, we can deploy additional machine learning models, such as we can create an assessment schedule and an annotated case report form from the protocol itself using a combination of machine learning tools as well as automation for things to write to PDFs. Second, we can help predict any sort of future resourcing needs. Another component which I'm excited for is visualization. We can create visualization templates that can be used to identify trends across studies in any study, such as adverse events per site, the total open and closed queries by site, and any sort of data entry lag. The huge advantage of data standardization here is one visualization template can be used, and because the variables are standardized and mean the same thing across templates, you can have an expected visualization that is meaningful. At this point, we're going to shift gears a bit and talk about some of the automation projects that have been undertaken at SDC. Both of them were greatly benefited by data standardization as well as other standardizations within the organization. The first is study access security. One promise that every CRO needs to fulfill is the security of data. Not only the security from outside groups, but also ensuring that only people who need access to the data have it, not everybody in the entire company. This project aims to automate that process. We integrate our file system with our enterprise resource planning software. And by doing so, we can accomplish the following. We can ensure resources are correctly associated with the projects within the ERP. We can also guarantee that the resource has correct permissions for their role, and we can eliminate the need for IT to manually change permissions. One exception here is all blinded data still goes through a rigorous approval process before access is granted, and that data is housed on a separate file system. So we do not have to worry about this automation interfering with that whatsoever. Now I would like to talk about the 3 items with a red border on the process flow in the left. First, a manager would add a user to a study, ensuring that the role that they have, that they will fulfill in the study is accurate. Different roles have different levels of access, and the same person can have different roles in different studies. Therefore, it is vital that this is selected correctly. For instance, in a study, the primary and validating programmers have different data access needs. When entered correctly within the ERP after the process runs, the user will only have access to the relevant data that they need for their tasks. On the left, we see input from business logic. Business logic was arrived at by having discussions with each department head about which parts of data are needed for their department and their roles to complete its task. In the future, should a new role be created or the needs of existing roles be altered, we have a change process in place to ensure that those changes are applied and output correctly from the software. Now, let's talk about the final 2 parts of the process flow. The software program itself takes all of the inputs, which include the change within the ERP system, the person, all business logic, and the current state of the file system. The software then returns a change in the file system, a reason for the change, and an audit trail. The changes include things such as adding a new user to a folder, blocking a new user from a subfolder, and removing previously granted access to the folders. In addition, another feature that we have from this software is when a new project is detected within the ERP, we automatically create new project folders on our drives with a duplicated file structure maintained by each department. There are several advantages here. First of all, we can ensure that all folder structures are identical for all projects. Secondly, when we name the project itself, we can ensure standardized naming conventions, so any automation software knows the sponsor and the project associated with these files. Finally, those file paths, along with the projects, are saved within our database, so when new users are added, we know where that path is, and we can add or remove the user as needed. Early results are promising. Right now, 9 studies are in our beta program, and we've had minimal issues that have been needed to be resolved to IT. We are hoping to move all studies to this system shortly. The second project I would like to talk about is our business development protocol bid automation. To complete the bidding process for new studies, input from operations is needed. This information is generally contained within the protocol. However, all protocols are formatted differently. The purpose of this project is to quickly extract the key information from protocols to facilitate business development bidding process, and then to put it in front of the BD representative to be able to respond in a quick manner for this process. The first step in this process is for that PDF to be uploaded to a monitored directory. At this time, we are only parsing through PDFs and we are not using Word files, and this is to simplify our process. That PDF is then parsed for keywords and tables. Some of the tables we are looking for would be the schedule of assessment. Other keywords include any sort of diary information, the number of subjects, the study duration, and we have about 10 other items that we are constantly looking for. The output here is a list of items parsed as well as the value for all of those items. Now that the data has been parsed from the PDF, we move into the second stage. And this is processing some of that data in a machine learning model and predicting output. This is because some of the values that are needed include things such as the unique TLFs. These values are not apparent in the protocol itself and have to be arrived at via a machine learning prediction. Some of the features that we use to make this prediction are the sponsor, the indications, the endpoint, the number of subjects, the phase, in addition to others. Finally, the predictions from this model, as well as the items that were parsed in the previous step, are put together and returned to business development. They work with the operations team to determine the accuracy, which closes our virtuous cycle loop here. Metrics for this are also promising. We are also fairly early in the process, but we are correctly identifying the schedule of assessment and transforming it as needed 95% of the time, while the other data has been correctly identified about 70% of the time. This has been done across 30+ protocols. These are not final protocols, but often they are works in progress, which makes it more challenging. If we were able to run this on a final protocol, I would expect those numbers to be much higher. However, the process does not allow us to run these on final protocols, simply the protocols that are in progress. The key takeaways that we would like for you to take from this webinar are: the standardization of naming conventions across the entire organization is the foundation for successful applications of artificial intelligence and automation. This is something that has been stressed quite a bit because while the payoff from it is not evident up front, almost any process downstream from the standardization benefits greatly and would reduce the hours, the complexity, and the tendency for errors. The combination of automation and machine learning will lead to a reduction in time needed to complete routine tasks, as well as increase the accuracy of those tasks. Neither one is a solution by itself, but rather they work very well in tandem, and we prefer to deploy them in tandem rather than individually. Thus, we have a staff that composes both software developers and data scientists to complete those machine learning models. Finally, those data scientists will leverage the virtuous cycle to allow for continuous improvement of model predictions. It is essential for this in order for the model to get better over time. It is expected all of our models will be more accurate a year from now than they are today due to leveraging the virtuous cycle. I would like to thank everybody for attending the webinar today. And now I'm going to pass it over to Adriana, who will host the questions and answers portion.
Thank you, Dale, Julian, and Barty for a great presentation. At this point, we will move on to the Q&A section of the presentation. For all attendees, please do continue to type in your questions in the comment section of the webinar. We've been getting a few, so I'll start with the first one I'm seeing here. Is the macro dealing with processing all data as far as control terminology is concerned?
Yeah, so control terminology is getting implemented for variables like test codes, test names for standard CRFs. But at this point, we have not extended it to other variables like units, as it does need some more processing, especially if we require converting collected original units into standard units and things of that nature. But it is something we're planning to incorporate in future and to ensure that we adhere to the standards for submission-ready data.
Great, thank you. Another question here. Is the AI algorithm transforming the data at all between EDC and SDTM, or are all the transformations done via the SAS programming?
Yeah, so the grouping algorithm that is used to output the spec sheet does not transform any data. Rather, it just groups the data and then attaches a standardized variable name when necessary. So there is no actual transformation happening from the grouping program itself.
Yeah, and I'd like to add to Julian's response. The grouping program is producing an SDTM spec, which is generally a very manual process. And now with the algorithm, it is automated. This spec that the algorithm produces, once reviewed, is the one that drives the SAS program, which actually does the data transformation.
Great. Another question here is, you mentioned several machine learning models today. Can you talk about what kind of model is used?
Yeah. So I did mention a handful of models. So for the data naming convention standardization, we're using a random forests as our model. We found that that's doing the best at the moment. We don't really have enough data kind of in any of our processes to do any sort of deep learning model. So these are the neural nets that you'll kind of hear about a lot because they're more cutting edge. However, some of these more simplified models I have found work very well. And then the other model that we have is for predicting unique TLFs. And so that model is a form of nearest neighbors.
Thank you. The next question here is, do you see the CRO industry moving in this direction? What prompted SDC to pursue AI/ML?
This is Dale. Yes, CROs as well as sponsors are in various stages of implementing AI and machine learning. SDC's initial and ongoing pursuit is multifaceted. Again, first, to standardize and automate the lower level processes to allow personnel to focus on higher level tasks, as well as to reduce processing time and maintain consistent quality. And then the second facet is really to better understand the data that we have to drive better decisions for our clients and ultimately for our patients.
Thank you, Dale. The next question here is, for study access security, has anyone had issues needing access to data immediately but not being able to get to it?
Yeah, I'll take that. I will say when we kind of announced the project and even the beta that we're doing with these studies, there was definitely low-level anxiety that they wouldn't be able to respond as quickly as necessary. But this process, and I believe I actually didn't mention it, is on a regular, it's automated every 20 to 30 minutes, we're checking. And so the lag that you would have is very minimal, which generally would still be better than any response that IT could have. So while I think going into the project there was some anxiety, none of that has been realized at this moment, and people have been happy about it.
Great. Again, thank you, Dale, Julian, and Barty. I also want to thank everyone who joined us today. We hope you enjoyed the presentation, and we do welcome you to continue to type in your questions. We will stay on for a couple more minutes to keep the portal open for any additional submission, but this does conclude today's presentation. Thank you.